Hi, Dr. Hendricks here. Welcome to the video on classification of matter. Alright, first we're just going to talk about how we can classify matter, and then we're going to look at different examples. So all matter can be classified as a pure substance or a mixture. Okay, and so we're going to talk about the difference between the two. Okay, a pure substance, hence the word pure, is a single component. Okay, this could be an atom or this could be a molecule. You'll see that we'll look at compounds. Okay, these are also considered to be pure. It has a constant composition throughout, so no matter what the sample is or where you get the sample from, or how big or small the sample is, it has a constant composition and nothing changes. Okay, it cannot be broken down by physical means or by physical change. Okay, that's the biggest difference here. So it can't be broken by physical means, and we're going to talk about what that really means here in a few minutes. Alright, so a pure substance. An example would be sugar, C12H22O11. Okay, if you have your periodic table, you may want to pause and pull it out or look in your book or pull it up on the computer. Okay, and if you also look at your periodic table, you will see that you have what we call compounds here as examples. So C12H22O11. So on your periodic table you have carbon, hydrogen, and oxygen. Okay, so this is considered a compound because they're put together in a definite ratio. Okay, water is also a compound, H2O. Okay, and so hydrogen and oxygen are both on the periodic table, and when they are combined, there's no way to physically pull them apart. Okay, so I can't get my water glass and pull out the hydrogens away from the oxygens in my water glass. Okay, I can't physically do that. Okay, mixtures have more than one component. So there's lots of examples of mixtures even just in everyday life. So your cereal or your vegetable soup, trail mix, things like that. So are mixtures of different foods or different things. They have more than one component, so they have varying composition throughout. They can be a mixture of solids and liquids or liquids and gases. It can be a mixture of our states of matter. And they can be separated by physical process or by physical change. So if you dissolve sugar in water, so you have sugar water, or you could think of the same thing as for salt water. Okay, this would be an example of a mixture because you have actually two substances put together. You have water and you have sugar. So earlier when they were separate, they were pure. But then if you mix them together, now you have a mixture, hence the word mix and mixture. Okay, a pure substance, the best way to look at this is that it can be an element. So if you look at the periodic table that I told you to pull out or have one handy, you'll see that all of the elements on the periodic table are the simplest, most pure form of matter, okay, of atoms. Okay, so anything on the periodic table by itself, so carbon, nitrogen, oxygen, the list can go on, those are all pure. That's as pure form as it can be. So they cannot be broken down by even a chemical change. Okay, it's the purest form. So elements cannot be broken down by chemical changes or by physical changes. Okay, and so here's an example on the slide here of aluminum and nitrogen. So both of these are elements. Okay, pure substances can be also elements or compounds. So earlier we looked at the compounds. We looked at sugar and water. Okay, and so here's some more examples. So a compound is a pure substance when you join two or more elements, like I mentioned before, and you chemically bind them together. So here we have water, an example. So H2O is one oxygen and two hydrogens chemically combined. And then we have salt. Okay, so salt is Cl. So sodium chloride's table salt. So if you look on your periodic table, you see sodium and chloride. They're chemically combined. Therefore, this would be a compound, but it is a pure substance. All right. So if we're classifying matter and it can be separated by a physical process, then we know this has to be a mixture. There's a little graph you can kind of follow through. Okay, so what do I mean by physical process? Okay, we've talked about physical changes if you've been watching all of my videos. So physical processes in a chemistry lab could be things like filtering, okay, or it could be things like decanting, where you pour off maybe the liquid from the solid or something. Okay, another example would be something like evaporation. Okay, so if you can do one of these techniques, of course there are others. Okay, if you can do these are physical processes. Okay, and so if you can filter it, or you can pull it apart with your hands, or you can decant it off, or there's some way that you can physically separate two components, then this is going to be a mixture. Okay, if you can't, then it's going to be a pure substance. And there are two types of pure substance. There are elements. So you would look at your periodic table. If it's an element, then it has to be a pure substance. And if it is a compound, okay, then it's going to be a combination of elements on the periodic table, such as H2O. Okay, and an element would just be in its pure form, something like copper or silver. Okay, you could go down the whole periodic table. Okay, and so here's a question here. Can it be broken down into simpler substances by a chemical reaction? Okay, elements cannot be broken down. It's as simple as it can be, so they can't chemically be broken down. Okay, however, compounds can. So we'll learn more about that later, about chemical reactions. Okay, and that's what we're looking at. We're looking at compounds and how they can react to form new compounds. Okay, but the main idea is knowing this with your physical process and whether it would be mixture or a pure substance. Alright, so here's some practice. So in these videos I'm trying to explain the concepts, but then do some problems or do some examples that can help you. Okay, so here we've got copper. It's showing us the element copper. It's giving us its atomic number and everything there, but it's a penny, of course. And so we are going to label it, and you can pause the video if you want to do these yourself. But this is an element. It's on the periodic table, so that classifies it as a pure substance. Okay, trail mix, I mentioned it earlier. We can physically take out the raisins and the nuts first and the almonds, so this we can physically separate it. So this would be a mixture. We call these heterogeneous mixtures when we can actually see the different parts and pull it apart. Alright, here we've got salt water. Right? This is a mixture. We saw it earlier. Makes me want to go and visit the beach looking at that picture. Alright, so we've got a mixture. Okay, salt and water can be separated by physical means. So we could, for example, we could evaporate. So if we boiled salt water and we boiled all the water off, then we would be left with salt in our container. Okay, and we actually do that in the lab here. Alright, here we have a bunch of compounds. So they are elements chemically combined to each other. So these are pure substances. Here we have oil and water, which don't mix. So this is a mixture. We combine two substances, so we made it a mixture. And this would also be heterogeneous because we can see the two parts. The salt water, pretending that it was crystal clear like it looks in this picture with just salt and water, this would be a homogeneous mixture because you can't see the salt. It dissolves in the water, so you can't see it like you can here where we can pull these apart. Alright, I hope you understand how to classify matter, and I will see you soon. Thanks.